try another example here. What if we're given 6x minus 9 squared equals 45? Since our exponent here is 2 and 2 is even, then we use the even root property. That means we have two solutions. So by simplifying the roots, this would be square root of 6x minus 9 squared equals square root of 45. So we have 6x minus 9 equals square root of 45 is 45. You can write this as 9 times 5. So 6x minus 9 is just equal to the square root of 9 is 3. So that is 3 square root of 5. So this is plus minus. Okay. So we add 9 to both sides. This cancels out. So we have 6x equals plus minus 3 square root of 5 plus 9. So our solutions are 6x equals 3 square root of 5 plus 9. And then the other one is 6x equals negative 3 square root of 5 plus 9. Then we can simplify by dividing both sides by 6. Okay, the same as here. This cancels out. So x here is just 3 square root of 5 plus 9 over 6. And here x is equal to negative 3 square root of 5 plus 9 over 6. Or you can just write this as 9. X equals 9 plus 3 square root of 5 over 6. And this one is 9 minus 3 square root of 5 over 6. And then we can simplify our solutions further because 3, 9, and 6 are divisible by 3. So our solution would be just, okay, x equals 3 plus square root of 5 over 2, or x equals 3 minus square root of 5 over 2. Okay, so when solving with exponents, it is important to first isolate the part with exponent before taking any roots. Say for example this one. We're given x plus 4 cubed minus 6 equals 119. So we need to isolate this part here, negative 6. Separate this with the exponent part. So we just have to add 6 to both sides to eliminate 6. So eliminate 6 on the left. So we are left with x plus 4 cubed, and then 119 plus 6 is just 125. Okay, our exponent here is 3, and 3 is odd, and so we can use the odd root property. Therefore, we only have one solution for this problem. So we simplify the roots, get the cube root of x plus 4 cubed, cube root of 125. So this is just x plus 4 equals 5, because 125 can be written as 5 cubed. Then we simplify, we subtract 4 from both sides. So our solution is 5. So x is just equal to 5. Okay, let's try another problem here. Okay. Okay, in this case, we have an exponent that is a fraction. So when our exponents are fractions, we will need to first convert the fractional exponent into a radical expression to solve it. So let's recall that a to the power of m over n is just equal to the nth root of a to the power m. Okay, from the law of exponents. So our denominator from the fractional exponent, it would become our root, and the numerator would become our exponent. So once we have done this, we can clear the exponent using either the even or odd root property. Then we can clear the radical by raising both sides to an exponent. And you have to take note that you have to check answers if the index is even. And I've already discussed this in the other video. So let's try solving this. We're given here 4x plus 1 raised to the power of 2/5 equals 9. So let's rewrite this expression, radical expression here first. So this one is just equal to the fifth root of 4x plus 1, okay, squared equals 9. Okay, then we can clear the exponent first with the even root property. So use the even root property. So we get since this is our exponent is 2 and 2 is even, then we can use the even root property. So this is just the square root of the square of the fifth root of 4x plus 1 equals the square root of 9. So we have two solutions for this. Okay, so this is just equal to the fifth root of 4x plus 1 equals plus minus 3. Okay, we can clear the radical by raising both sides to the fifth power. So we raise both sides to the fifth power. So we are left here with 4x plus 1 equals plus minus 3 to the fifth. Okay. Then we need to solve two equations here. So we have two equations. We have 4x plus 1 equals plus minus 243, because 3 to the fifth is just equal to 243. So our solutions would be 4x plus 1 equals 243. Then 4x plus 1 equals negative 243. Okay, and solving for x, we subtract 1 from both sides. This cancels out, so we have 242. Divide both sides by 4. So our x here, our first solution, is just equal to okay, so they are both divisible by 2. So this is 121 over 2, because 242 is not divisible by 4. And then here, the other solution, we subtract 1 from both sides. So we have 4x equals negative 244. Divide by 4. So our x here is just equal to negative 61. Okay, so these are our solution. Okay, let's try another example here. So what if we're given 3x minus 2 to the power of 3/4 equals 64? First, we will write the radical expression. So we can write this as the fourth root of 3x minus 2 to the power of 3 equals 64, and then we clear exponents by getting the root, so the cube root of both sides. So cube root of the cube of the fourth root of 3x minus 2 is just equal to the cube root of 64. Okay, our exponent here is an odd number, so we use the odd root property. So this is just equal to the fourth root of 3x minus 2 equals cube root of 64 is just 4, because you can write 64 as 4 cubed. And then, okay, next is, okay, our index here is 4, and 4 is even, so we need to check our answers later. So we raise this, we raise both sides by 4. So we have 3x minus 2, and 4 to the power of 4 is 256. And then we add 2 to both sides. This cancels out, and 3x is equal to 258. Therefore, by dividing both sides by 3, okay, 3x over 3, 258 over 3, x is just equal to 86. Okay, since our index here, 4 is even, then we need to check our answer to find out whether the x equals 86 is a solution to this problem or an extraneous solution. So let's try plugging in 86 to, okay, so that is 3 times fourth root of 3 times 86 minus 2, okay, cube is equal to 64. So 3 times 86, that is 258. Okay, let me write that. 258 minus 2. Cube equals 64. 256. Okay, so fourth root of 256. So 256 can be written as 4 to the fourth cube. So this is just 4 raised to the power of 3, 64. And 64 is equal to 64, which is true. So that means x equals 86 is a solution to this problem.